everyone for joining. It is my extreme pleasure to introduce our invited speaker today, Daniel Greene. Daniel is an assistant professor of information studies at the University of Maryland. His ethnographic, historical, and theoretical research explores how the future of work is built and who is included in that future. His first book, The Promise of Access, Technology, Inequality, and the Political Economy of Hope, was published by MIT Press in 2021. It received the McGannon Prize for the Best Book of the Year on Media and Activism. This talk draws on research Daniel has conducted with Anna Lauren Hoffman from the University of Washington. Daniel, we're very thankful for your time and very excited for your talk. So the virtual floor is all yours.
Thank you, guys. I'm so excited to be here today. Let me get this going. Okay. And all right, coming through okay? All right, awesome. Okay, so afternoon, everybody, or morning, depending on where you are. Thanks for Ibrahim in particular for setting this up. Like you said, I am a professor of information studies at the University of Maryland. Prior to that, I was at Microsoft Research. My background is in the sociology of labor and technology. And one of my collaborators joked that it was pretty funny for me to be here today giving a talk about AI ethics, because as a Marxist, I obviously have no ethics whatsoever. And that is a bit of a joke, but I do want to, take pretty seriously here a materialist approach to talking about exactly where this kind of latest boom in AI ethics come from, something that really, did not exist in the form that we have it today 10 years ago. But first, I want us to all kind of come to a common understanding about the kind of harms that we're trying to address together, because we've seen a lot of prominent ML screw ups in the last few years, moments when automated pattern discrimination, which is really just what machine learning is, goes wrong. And these will be familiar to a lot of us, So for example, facial recognition systems have labeled Black folk as gorillas. It's from Google. Virginia Eubanks showed that the automated review of Medicaid applications in Indiana during the Mitch Daniels administration flagged any discrepancy in the documentation as a failure to cooperate. And all this meant that was 1 million people, largely disabled folks, were kicked off their health care. And ProPublica famously found that the risk score algorithm Compass, used in Broward County, Florida to inform bail decisions, had equal error rates for Black defendants and white defendants compared to future arrests. But it was twice as likely to label Black defendants as future criminals compared to white ones. So these are the sort of paradigmatic cases that bring, our sorts of people together. We might also think about, for example, the self-driving car that killed Elaine Herzberg in Arizona, or, seemingly nonstop incidents of political radicalization via YouTube. We're all familiar with this kind of litany of harms. And what I want to ask today is, why does this keep happening? And a deeper question, why do we feel like this is wrong? Some sort of violation of the social contract that is somehow different from dumb, biased humans making dangerous choices. What's different about this? So my interest in ML and AI is not in particular technical advances or performance benchmarks, or, frankly, in philosophical questions about what makes our minds different from the machine. Instead, I'm really interested in two things. First, the politics of bureaucracy, how decisions in large organizations get made and how that changes people's lives in ways they may not even understand. Sometimes it's a human process, sometimes a technical one, usually both, and it's been that way for a few centuries. And the second thing I'm interested in is the sociology of ethics, not these normative comparisons of different ethical models, what is good and what is right, but rather I want to try to explain why certain modes of ethical reasoning gain traction when and where they do. And this is what the title means today. The problem of machine learning is human-made, and so are the ethical responses to it. Both are the products of political struggle. Both can be changed by those same struggles. Both our systems and the way that we respond to them are products of social conflict, and they could be otherwise. So this talk draws on years of research and collaboration with brilliant colleagues in industry, academe, and activism, including computer scientist and entrepreneur Genevieve Patterson, organizer and political theorist Sarah Hamid, who was just hanging out with last night, philosopher Anna Lauren Hoffman, and historian of science Luke Stark, who is at Western for the Canadians here. In particular, this talk draws from an IEEE Spectrum article I wrote with Genevieve and some papers I wrote with Luke and Anna, all of which are available on my website. So I'll talk for another 40 minutes or so, and then we'll discuss. And first, I'm going to talk about what it looks like when machine learning deployments go wrong. And my interest here is in building a kind of a schema by which we can classify the different kind of harms that broken ML can visit upon people, so that we have a vocabulary with which to define the problem. And then second, drawing on the work of sociologist Gabriela Bend, I'll explore the dominant response to these problems, proposals for more ethical design of AI and ML. And my interest here is descriptive, not normative. I want to understand what people mean when they say that the solution to broken systems for hiring or bail is to build more ethical machine learning systems. How, after all, can a model be ethical? Where does that belief of ours come from? And finally, I'll compare the movement for ethical design with nascent activist alternatives in the labor movement, Black Lives Matter, and immigrant rights organizing that attack the very same problems, but with very different language and very different responses. Because we know that defining a problem also defines its solutions. We know that, for example, defining the racial achievement gap in American education in terms of test scores, if we define it in terms of test scores, if we define it in terms of problem of instruction, that suggests certain solutions. Teacher training, you link teacher salaries to test scores, whatever. Whereas if we define it as a problem of poverty, that suggests other solutions, free meals, free laptops, that kind of thing. And my goal today is for us to ask together, what kind of political problems do automated decision-making systems pose, whether they're broken or not? And how do we as a society come to agree on a definition of that problem? So we had an AI boom before in the 60s and 70s, followed by a long AI winter. And the first boom tried to build AI in a manner, fairly analogous to Chomsky's universal grammar and linguistics. You code the hundreds or thousands or millions of rules that, say, a conversation would require in advance. And that failed. It turns out people are much more complicated than we anticipated. And our present boom is largely owed to two advances. One, a set of researchers, largely Canadian, I am required to note, who kept up with AI through the winter and developed techniques that we today call neural networks, which mimic brain behavior by learning from large data sets to develop pattern discrimination rules for particular domains. And two, the availability of those same large data sets, many thanks to Facebook, for example, where everyone will label millions of photos for free, as well as the means to store them. So now we have the talent, the power, and the data through which we can develop machine learning models that either act on rules we established in advance, supervised learning, or through rules they develop as they go, unsupervised learning. This is a massive technical advance, and it's not surprising that it's been integrated into a host of different domains, very quickly, often without much anticipation of the consequences. But we keep seeing these same mistakes, and sometimes, for something like bail or benefits decisions, there are life and death consequences for these broken systems. So why do they keep happening, and how can we categorize their failures and their harms? So I want to talk about the different types of harms that can come from machine learning with headlines from the news, but also one extended example that shows how one system can or could break in different ways. So this is the system was the focus of my and Genevieve's Spectrum article. You're all probably familiar with the company Taser that made stun guns for police. A few years ago, largely frankly, a cash grab after the success of the Black Lives Matter movement. Taser rebranded as Axon. And today they own most of the body camera market for police in the US and are expanding very rapidly across the globe. The actual body camera hardware is just a couple $100, and you don't need to replace it that often. So the big money is in a long-term subscription service. You have to offer cloud services that justify the expense and incur subscription costs year over year. So the way Axon sells those subscription costs to police departments is by saying, if you buy our body cameras, not only will we store the footage, but we'll help you develop permissions for who can see it. We'll automatically redact it with your help. Basically what happens there is that an officer looking over video that's going to be released publicly, like draws a box around someone's face. And then most of the time, Axon software keeps the box following that face throughout. And in the future, Axon is promising that, having learned from the millions of annotations that police make on body cam video for police reports, they say that they will automatically generate police reports from that footage, thus eliminating the tedious paperwork that all police officers hate. What could possibly go wrong? So as the place where policing and big tech meet, Axon has been the focus of a lot of activist protests. And because of this, they recently, not so recently now, like 2 years ago, said they will not introduce face matching technology into their body cameras at this time. They won't, connect it to a driver's license database. However, obviously, they still need to have face detection just for redaction purposes to work. So this is not a difficult lift, technically. Whether it works is a separate question. Politics is a social system of collective deliberation, decision-making, and collective distribution, resource matching problems. And like any other kind of political problem, I think you can broadly group the harms of broken machine learning systems into outcome harms, the stuff that you get as a result of a decision, and process harms, problems with how the decision was made in the first place. So the first outcome harm is misrecognition. And this is when an institution fails to recognize you or recognizes you in a way you would not prefer. Anyone who has dealt with citizenship struggles or had trouble importing their name into Western naming conventions and Western institutions will know that this is not just an ML problem. So whether the state would recognize gay folks' marriages as legitimate is a good example of like physical recognition. Whether Google Images calls Black people or gorillas is a good example of computer vision misrecognition. The explanation for the latter is obviously pretty simple, right? So of the millions of faces it was trained to recognize, it probably had far fewer Black faces compared to white faces, especially in the the really good lighting that we associate with professional photography, especially stuff from Hollywood or from stock images. And so it overgeneralized and thought Black folks were apes. And this is a vicious racist insult. It's perhaps not deliberate, but it's also not an accident. We should know our training data, and these blind spots are telling us about what happens at Google. This tells us something about their labor process. Wendy Chun over at Simon Fraser, always says that these kind of audits, these kind of mistakes are not accidents. They're like free audits that we're conducting for these companies. They're telling us what the problems are. This should be obvious. They don't like that, but hey, it's helpful. How might this problem repeat with police body camera data? So, we can imagine that the training data includes high profile arrests with extensive detail, for example, for folks wearing masks, maybe like balaclavas while they commit robberies or something like that. And if that data includes more people with balaclavas than it does, for example, women wearing burqas, and thus cannot distinguish between a balaclava and a burqa, then automated reports might label burqas as masks and encouraging greater suspicion, if only because of greater time and analysis, of Muslim women. The second outcome harm is misallocation. So when an institution does not fairly distribute its stuff, and this could be either getting not enough of the good stuff or getting too much of the bad stuff. So we could think here about the long history of environmental racism in the US and Canada, where we know that highways and garbage dumps are more likely to be near Black and Indigenous communities than white ones. Because machine learning is often deployed as a kind of a pattern discrimination technique, it's a category generating machine. The harms of misallocation flow naturally from the harms of misrepresentation. ProPublica's story is a really good example here. It's no wonder this is the thing that frankly starts a lot of our fields. So because the harm of misclassifying Black defendants as more likely to recidivate than white defendants, even when controlling for their records, creates another harm because they get different jail times and different bail amounts. They have to pay more to get out of the cage. Similarly, in our burqa example with Axon, the misclassification of burqas as masks leads to misallocation. You get more intensive police attention to Muslim women who aren't doing anything, they're just going about their day. And this is, obviously, this is the same thing that the NYPD got sued for under Mayor Bloomberg for stop and frisk. It's just faster. It has this veneer of technological objectivity to it. And the second set of harms are less about the result of a decision, who gets what stuff, than how it gets made. And this is the core of democracy, right? Having some kind of, if messy and imperfect process for including as many voices as possible and making it fair and transparent. We live in representative democracies where some people make decisions for us. They're not direct democracies, but they're supposed to offer an explanation of it. We're supposed to have input. We're supposed to have the ability to respond to them if we don't like the decision. So, for example, it's not really important whether a judge believes in their heart of hearts every word of the written verdict that they issue when giving a decision, okay? What's important is that the verdict is written in the first place and that it's public. And thus people can appeal the verdict based on the reasoning therein, or future decisions can build on that verdict. Case law is precedential. It's a receipt is all it is, really. And one of the primary concerns about machine learning systems is they are black boxes that don't give receipt. We don't know how they came to their decisions, especially in unsupervised systems, because they don't think the same way we do. We know the inputs, we know the outputs, but replicating the path from A to B can be pretty hard. And this lack of explicability is a technical problem, of course. Explainable systems are accountable systems. Lots of great work on explainable AI going on right now. But frankly, it's compounded by a legal problem that has nothing to do with software development. Because privately contracted systems used by public agencies are nevertheless the property of that original private company. And thus the reasoning by which the machine reached its decision is often protected as a trade secret. So for example, take this Compass risk score algorithm. A defendant in Wisconsin named Eric Loomis sued the state because he thought the use of the Compass risk score algorithm, which is supposed to be an advisory tool, he thought it influenced the judge's decision to give him 6 years for, I think, burglary. And the defendant said that it violated his rights to due process because he didn't know how the Compass made its decision, and no one did. So he sued and he lost, and he's in prison. He's finishing up a 6-year sentence. So these decisions are both technically and legally opaque. Elizabeth Joe at UC Davis has done a lot of work on this. And of course, bureaucrats or cops make bad decisions all the time, and they might not be able to give a great account of them. That's normal, that's people. But at least they can be called to testify in the court of law and held responsible for that decision, no matter what the reason we made it. We can't do that for Compass. So in our hypothetical Axon example, we can imagine a class action lawsuit against the company for its automated suspicion of women in burqas being refused certification in the first place, both because no explanation is forthcoming and because any explanation would be protected by trade secrecy privileges. Finally, there is a process harm in speed, which denies an opportunity for appeal in the first place. So much of democracy is quite slow. And this can be very frustrating for reformers of any kind, whether they're engineers or lawyers or whoever. And it can be harmful too. But oftentimes things happen slowly for a reason, and that's to get maximal input, to go through all the rules that you need to make a decision, and to open up those decisions to appeal by the affected parties. Automated pattern recognition for political decision-making necessarily occurs too fast for the affected parties, much less regulators, to intervene. And this was the harm that Virginia Eubanks found in the automated processing of Medicaid applications in Indiana 10 years ago. Any mistake in the form meant that the form was automatically rejected as a failure to comply. And this made the processing of paperwork much, much faster. But at least when things were done by slow, dumb humans, you could call them for an explanation. And those humans might be racist, they might make bad decisions, but there is a method for appeal. And Axon's pitch to police is that it will eventually eliminate the tedium of paperwork. And that really can sound great. You get more boots on the street, whatever. But that paperwork has an important function because each memo, each case report, each arrest report, each time clock is a moment of accountability. It's a paper trail, and it's evidence of a process by which the officer must stop and consider how and why a decision was made, and a point of intervention for superiors or regulators or citizens. They might not be honest, but we can track it and bring it to court. The threat of further paperwork can often be an accountability measure in itself, frankly. And this is one reason why it's been such a long fight in my home city, in DC, to have our local police release data on who they stop, when, and why. Because each slowdown, each time they have to document that decision-making process, is a point of consideration for whether or not something is just or necessary. Democracy in many ways purposefully inefficient. All right, so this is the problem as I see it. There are harms in outcome and process that machine learning implementations and public agencies have wrought, and it is these harms that have provoked a lot of research, activism, and soul searching among people designing these systems and clamoring for solutions to their problems. The 2016 election and the specter of fake news, an underdefined term, but a big problem, was also a big one. And over the last 7 years, one big trend has emerged as a solution to these problems. A movement for the ethical design of AI and ML that presupposes that a lack of ethical training and ethical consideration in the design and implementation of these systems causes negative political outcomes. This is why FACT exists as a conference now. It's why there's so many fights over NeurIPS, because we are trying to build these things better. Indeed, Axon itself created an ethics board with outside experts in robotics, policing, law, and computer vision to show how serious it was about this problem. So in my remaining time, I want to explore how these technologists and regulators have defined this problem and what they mean when they say we need ethical machine learning. And here I'm particularly inspired by the work of sociologist Gabriela Bend, who studies what he calls the moral background. And this is kind of second order ethical thinking beyond the content of specific values or norms. You can think of it as a grammar that specifies the kind of ethical reasoning we use, the language we use, the examples we draw on, that kind of thing, the things that differ very much between cultures. And in this way, I ask what kind of problem ethical machine learning is and what solutions flow from that framework. And I'll conclude by offering some alternatives. So obviously there's a long history of professional ethics in fields like engineering, architecture, and medicine, but I think we can trace the present ethics bonanza to the Obama administration. From 2014 to 2016, President Obama and the White House Office of Science and Technology Policy identified big data, remember big data, as both a strategic priority and an area of legal and ethical concern. In a series of reports, the administration made a commitment to support big data's, quote, enormous potential for positive impact, while also, quote, ensuring that it does not create unintended discriminatory consequences. These reports framed concerns over discrimination explicitly within the context of American civil rights legislation, focusing on algorithmic systems and automated decisions that, quote, inform decisions that affect our lives, such as whether or not we qualify for credit or employment opportunities, or which financial, employment, and housing advertisements we see. The experts involved in these efforts would go on to staff many of the institutions we now identify as leaders in this fight, Data and Society, AI Now, they run FACT, they chair portions of NeurIPS. A lot of them end up back in the Biden and White House in their Office of Science and Technology Policy. And they also go on to author many of the examples that I'm going to bring up in a second. The examples also that OSTP brought up still dominate the conversation. We have this kind of repertoire of examples that I started with here. Automated jobs or decision making, the fairness or unfairness of black box decisions like Compass. And beginning in 2017, we saw an explosion of research, policymaking, and position papering over ethical machine learning. And every day we see new think tanks like OpenAI or AI Now, conferences like FACT, corporate advisory boards like the Partnership on AI to Benefit People and Society, Axon's own ethics board for public safety, We have this, flood of internal corporate ethics statements from Google and Microsoft, new nonprofit ventures like the Montreal Declaration on Machine Learning and Human Rights, new academic units like MIT's Schwarzman College, an explosion of required ethics classes in computer science or information science, on and on and on and on. Everybody wants ethics, but it's not clear what ethical AI or ethical ML means. For example, Joy Buolamwini, then grad student at MIT, soon to author the, well, actually, no, this was at the point where she did author the groundbreaking gender shades paper with Tamit Gebru, who was then at Google, since very publicly fired, wrote an excellent and highly publicized paper called Gender Shades that demonstrated the failure of machine learning-driven facial recognition technologies to recognize people of color, especially Black folks. She and Tamit argued, quote, "You can't have ethical AI that's not inclusive, and whoever is creating the technology is setting the standards." Responding on Twitter, sociologist Alondra Nelson, then president of the Social Science Research Council, soon to become chair of Biden's Office of Science and Technology Policy, a job she just left, responded, she noted that while algorithmic accountability is important, quote, "I struggle to understand why we want to make Black communities more cognizant in facial recognition systems that are disproportionately used for surveillance." After all, like, I can't buy a facial recognition system off the shelf, nor do I have anywhere to install it, right? Like, I don't have a system with cameras. These things are only used by people with, enough capital to spend, enough place to put it. So where Buolamwini's quote framed inclusion as a fix to faulty technical systems, Nelson's framed inclusion as a threat to Black communities historically targeted by surveillance technology. And the point here is not to say one of these people is right, but to show that they are speaking they're using the same words, but speaking two different languages. And this is a very far cry from earlier debates over the ethical responsibilities of science and technology. So when Karl Popper gave a lecture to the International Congress of Philosophy in Vienna in 1968, he noted that everybody in the room was perfectly clear before he even started talking that his title, The Moral Responsibility of the Scientist, was, quote, "a euphemism for the issue of biological and nuclear warfare." Everybody knew why they were there and what they were talking about. They were not speaking two different languages. The gravity of these technologies helped focus the minds of the attendees. This shared consensus on the moral responsibility of computer engineers and data science towards their own inventions does not yet hold today, although I think we're getting there. Whether that's good or not, we can't even agree, frankly, on the problem, much less to solve it. Instead, we have this burgeoning movement of ethical design that is attempting to foster this consensus. And I think we're almost there compared to where we were in 2017, or at least it's kind of formalized the terms of that debate. So to study this, we collected these value statements on AI and ethical machine learning meant to guide their development, implementation, and regulation. And we've updated this in 2019 with another dozen or so. The oldest from OpenAI was from December 2015. The newest, the Toronto Declaration, was from May 2018. There was another explosion in like late 2018 when we updated the analysis. Nothing really changed. And some of these documents take the form of lengthy legal declarations like the EU's. Others are descriptions of problem spaces and the projects that those agencies will pursue in those spaces. Some are sponsored by Google or Amazon. Others are a collection of lawyers or researchers. But I want to ask us today, how do these values manifestos define what kind of problem machine learning poses and what kind of solution ethical design presents to that problem? What are the assumptions that ground these ethics manifestos that we're all swimming around in these days? What are the norms that they suggest? And the first thing to note here is the legitimation of design as a site of ethical inquiry. For people like me with a background in science and technology studies who are, spent decades complaining that technology is not neutral, usually we were ignored. This is a big deal. Like, this is major progress. It's clear everywhere that designers' values matter because they end up in the design, and building from that, we found 7 other kind of main themes. First, while statements usually differ as to why machine learning is a matter of ethical concern, all of them agree that A, their positive and negative impacts are a matter of universal concern for the whole species. B, there is a shared language of ethical concern across the species. And C, those concerns can be addressed by objectively measuring those impacts. That's where we start getting into audits. Often this ethical universalism is justified by reference to a kind of hazy biological essentialism. So the core argument of the Center for Humane Technology, which is largely former Facebook and Google designers, is that social media is hacking our attention and that human brains cannot adequately cope with these addictive designs. There's a lot of cartoon brain imagery on their site and in a Netflix documentary they produced. Second, and despite a universal community of ethical concern, these vision statements are never mass mobilization documents. Rather, they frame ethical design as a project of expert oversight, wherein primarily technical and secondarily legal experts come together to articulate concerns and implement primarily technical and secondarily legal solutions. In describing their work, the Partnership on AI separates out engagement of experts, the scientists and builders, from engagement of other stakeholders, individuals and organizations disrupted by AI. Experts make AI happen. Other stakeholders have AI happen to them. Third, these envisioning documents all offer, frankly, deterministic framings of machine learning as inevitable world historical shifts. Paradoxically, AI and ML, which I'm using interchangeably here, even though they're not, are also at the same time described as values-driven insofar as human beings create them. They are forces to which we must adapt, but which we are also responsible for. The Montreal Declaration captures this tension well. So there are sections headed by specific values, such as justice, that veer between instrumental impact, for example, what types of discrimination could AI create or exacerbate, and active human agency. For example, should the development of AI be neutral, or should it seek to reduce social and economic inequalities? It is taken as a given in these documents that these technologies are coming, that they will replace a broad swath of human jobs and decisions, and consequently, ethical debate is largely limited to how to design and implement those systems. And that perhaps resolves that paradox of values-driven determinism. So human agency is integral to ethical design, but is largely property of experts who are responsible for those designs. It's not a problem for everybody. Fourth, and proceeding from values-driven determinism, we find that these value statements focus primarily on technological design as the locus of ethical scrutiny, to the exclusion of business practices. And this is not particularly unique in the history of business ethics, but it's important here because the cutting edge of the field, due to the enormous amount of money that is necessary to train ML, store the data, and implement the code, this is largely the province of those huge corporations which fund, for example, the Partnership on AI or OpenAI, who also have a habit of acquiring smaller upstarts. Indeed, FACT itself was in large part a creation of my old employer, Microsoft Research. Fifth, and an important consequence of business practices being off the table is the implication that better building is the only path forward. We hear a lot of affirmative statements about what AI should do, and very few red lines about what it should not do. For example, Axon's ethics board announcement frames their initiative as the responsible shepherding of innovations designed to improve policing. CEO Rick Smith says the ethics board, quote, was created to ensure any AI technology in public safety is developed responsibly. In a comment to the Washington Post, Smith echoed the values-driven determinism I described earlier, saying, quote, it would be both naive and counterproductive to say law enforcement shouldn't have these technologies. Of course, Axon's ethics board has no veto power. Feedback from the ethics board led to Axon announcing they will not include face matching tech in their product at this time, though obviously they need face recognition for redaction, but that's not a binding decision. They can change that whenever they want. 6, these values manifestos seek to keep the conversation going, engaging as many stakeholders, again, largely experts, as possible. This positions ethical design as ethical because it is given a thorough vetting. This is, procedural justice. Vetting legitimates decisions through an appeal to transparency, but without specifying any subsequent substantive commitment. And this legitimacy holds even if, as in Axon's case, consulted stakeholders are limited in their capacity to impact design. Indeed, it appears as part of the mission of Axon's ethic board is to simply release reports that, quote, demonstrate a commitment to public transparency. You know, the important thing is that we're all talking. It doesn't matter what happens afterwards. Finally, in our last theme, the broad circle of expert consultation is also extended to AI and ML technologies themselves. Vision statements position explicable and transparent systems, as opposed to black boxed ones, as both a foundation of moral machine learning and a means by which moral questions are pursued. So under the Montreal Declaration's value of knowledge, there are questions posed not just about what AI means for human knowledge. For example, does the development of AI put critical thinking at risk? But what knowledge humans should have about AI. For example, is it acceptable not to be informed that medical or legal advice has been given by a chatbot? This dual emphasis makes clear that the proposed principle that follows, quote, the development of AI should promote critical thinking and protect us from propaganda and manipulation, is conceived of as a two-way street. You know, moral machines not only shield us from fake news, they make their inner workings clear enough to ensure that no fake news lies within. So we identified these 7 core elements of ethical design's moral background: universal concerns, objectively measured, expert oversight, values-driven determinism, design as the locus of ethical scrutiny, better building, stakeholder-driven legitimacy, and machine translation. What unites them together? 2 things stand out. First, conversations around the design and deployment of ethical machine learning are taking place among experts well aware that they are under public scrutiny. The prospect of massive job losses and rigged elections has raised the public profile of their work. Construction of a moral background for ethical design is partly about generating that moral consensus that Karl Popper knew already existed on nuclear and biological weapons. You know, they want everyone to agree on what the threats are, who should respond, and how. The problem remains, in this view, fundamentally technical, secondarily legal, shielded from democratic intervention. It's an inevitable result of progress. Second, and perhaps to the surprise of critical researchers who've been engaged in this work for decades, like myself, like many of you, ethical design seems to share many conceptual similarities with fields like science and technology studies. Facts, Principles for Accountable Algorithms, which was drawn from a Dagstall seminar, makes it clear that, quote, algorithms and the data that drive them are designed and created by people. There is always a human ultimately responsible for decisions made or informed by an algorithm. And this paints a very clear picture of moral causation, okay? Poor ethics lead to bad design, which produces bad outcomes. And this is a non-obvious conclusion, you know? We could just as easily, instead of ethics, blame business models or just the chaotic encounters of dumb machines that we can't predict in advance. It doesn't have to be ethics. And this presents a new problem for social scientists like me, who are frankly used to being ignored, you know? What if instead of being brushed aside, our critiques are being heard and then transformed into something that we might not recognize? I love these guys. They're everywhere when you start Googling like AI ethics. So what we've seen here is a burgeoning effort to define the moral background of ethical design. It's still in flux. It's still being formed. But I think it's, you know, at this point, a lot more solid than it was 7 years ago. It looks like this. People are going to lose their jobs. Parole and credit are going to be dictated by algorithm. That's inevitable. What we need is a set of responsible technicians and lawyers who can make that algorithm legible to the people it affects and minimize the damage it produces without cutting too much into the bottom line. But precisely because these ethical rules are up for grabs, precisely because there's something we fight over, me and my collaborators all think that this is a valuable moment to learn from other movements who are also trying to minimize the damage of AI and ML, but are using very different ideas from this kind of professional ethical approach. What does this look like? 2 examples. So the movement for Black Lives was kicked off in 2012 by Alicia Garza, Patrisse Cullors, and Opal Tometi after George Zimmerman's acquittal for the murder of Trayvon Martin. The Movement for Black Lives policy platform provides a useful contrast to ethical design manifestos. Theirs is an abolitionist project, organizing politically to create a world where police and prisons, violent institutions bad at solving social problems, are unnecessary. And under the section of the manifesto entitled An End to Mass Surveillance of Black Communities and the End to the Use of Technologies that Criminalize and Target Our Communities, the policy platform addresses many of the same technologies that our ethics manifestos discuss, Compass and stuff like that. Axon shows up in there. And they frame the solution as increased democratic oversight of technological procurement. In the US especially, these are very local decisions. So like city councils and stuff like that, making decisions about what kind of policing technology to buy. And this perspective differs from ethical design in two important ways. First, the project of defining harm and redress takes a much longer view that denies any kind of universal human concern. So while everybody might benefit, this is clearly a historically specific problem that especially afflicts Black Americans. Second, rather than starting with the principles that you think will move the world forward, the Movement for Black Lives platform starts with its vision of the good life, abolition, and works backwards from there, identifying general principles and the specific fights that they imply. You're deciding where, you're identifying pressure points, building a power map, as we say. This is a mass mobilization document. It embraces conflict. There's no conflict in our ethics manifestos. We all pretend that we all agree on this stuff. The second movement is also young, but with deep roots. The Tech Won't Build It campaign began in 2018 when Google's employees organized against the Pentagon's Maven contract that was supporting targeted killing systems. This was especially important because there are so many immigrants in tech. And in 2018, folks who felt that they were, building systems that would be used by the military to bomb their family in Pakistan, or to snare migrants who looked a lot like their parents. That was a big thing. And it picked up once employees in multiple companies, went off when I was at Microsoft, Salesforce, Amazon, Palantir, more. They started discovering their company's contracts with ICE, and this was at the peak of Trump's decision to jail families and separate children. Workers at all these companies staged protests and work stoppages. They made open letters that illustrated the gap between like corporate values and corporate practices. And they organized in solidarity with each other and other groups affected by their surveillance products. They worked very closely with immigrant rights groups, especially Con Mi Gente. Tech Won't Build It is broadly a movement for workplace democracy, holding that the people who make the stuff should have a say in how it's used. And this is, again, distinct from ethical design's focus on expertise, because tech workers are here claiming a seat at the table, not because of their technical qualifications, but because of their strategic position in the production process. It's a statement of legitimacy, but it's also, frankly, a threat. Again, conflict, because of that strategic position. In contrast to ethical design, there is an explicit focus on reducing profits, or at least redirecting them away from war or ethnic cleansing, because you're already making enough money selling ads, and this other stuff might scare away new recruits and investors. There's also often a kind of interesting loyalty to the craft and the company in these campaigns. So we saw today that the category machines that we call machine learning models can harm both the political process and the outcomes of that process. The dominant response to that has been an elite process to engineer an ethics that will take the harsh edges off those engineering problems. And this is a live question, it's not settled. And I think one of the advantages of taking this kind of sociological approach to ethics, just like any kind of social critique of technology, is show that it doesn't have to be this way. The different moral projects are possible. And indeed, many of them exist out there in the world, and they have deep roots in abolitionist or labor organizing projects that go back many, many decades. Both technology and the ethics of technology are made by people, and thus can be made or remade by people. Thank you.